Good morning, geometry, and welcome to our first day of some trigonometry introductions. I'm just going to talk really quickly about the word trigonometry. Trigon, obviously, is for triangles, and metry is for measuring. Those are Latin roots, so we know what we're talking about, measuring triangles. This is something that mathematicians figured out really early on, this idea that if we have similar triangles, here's a 5 by 3 right triangle. These are all right triangles. Here's 15 by 9, so this is a triple enlargement. And here's 55 by 33. This is like times 11 even, right? They found that if they were to look at some of these ratios, like 3 to 5, which is 0.6, or 9 to 15, which is also 0.6, or 33 to 55, it was also 0.6. So they found that looking at the ratios, they were always the same. So they thought they could really use that about this, because obviously if this is a 31-degree angle, that's a 31-degree angle, that's a 31-degree angle. So that's the whole concept behind using trigonometry, is using the ratios of the parts to figure out what the angles are. So let's just kind of talk about what some of these ratios are. This ratio that we're looking at right here, if we're talking about this 31-degree angle, the ratio, and I would take notes as we go, and you can pause the video frequently. The ratio of the opposite leg over the ratio of the adjacent leg is what we call tangent. That is the tangent ratio. So this is what we're looking at here. If we're talking about this 31-degree angle, the opposite leg is opposite the angle, and adjacent is the one touching the angle. Same here, the opposite leg over the adjacent. Opposite, if we're talking about this angle, right? It's always the opposite is the leg not touching. So let's just talk about what the ratios are, because there are a few different ones. So we know this ratio right here is just the tangent. And if we just talk about the tangent ratio for a second, actually, let's just do a problem that might make a little bit more sense. The problem would be like, say I'm looking at a tree, and I don't want to use, shadows. There's no shadows. It's cloudy. I don't have any mirrors in my pocket to measure how tall this tree is, but I need to know how tall the tree is. Well, if I put my head way down there on the ground and I use something called a clinometer, it'll measure the angle of elevation, and I can look and spot the top of the tree. And then I can measure how far away am I to the base of the tree. And let's say I'm 36 meters. I can figure out how tall that tree is right now. So what would we need to do? We would need to look at this ratio and know, if I know a 31-degree angle, I know that I can use a ratio. And the ratio that I'm going to use is I've got the opposite side and the adjacent side, and I know that is the tangent ratio. So the tangent of a 31-degree angle is going to equal the height of that tree, the opposite side, over the adjacent side, 36 meters. And then I'm going to solve that for h, right? So the way we can solve this for h is the way you guys have been doing this for a long time. I could put this over 1 and say the tangent of 31 times 36. So I'll even write 36 times the tangent of a 31-degree angle equals h. And on a calculator, I'm going to grab one so you can sort of see what's going on here. If I turn a calculator on, the first thing, if you're just using a regular calculator, you're going to need to make sure that when you hit mode, I'll try to get that exact. It's hard to see that exactly, but when you go to mode, the third one down is 1, 2, 3. It says radians or degrees, and you want to hit enter for degrees so it stays over on the word degree. And then you can go, we'll hit clear. You can hit something, let's just type it exactly this problem. 36 times the tangent, here's your tan button, right? The tangent of a 31-degree angle, close your parentheses, is 21.6. So we've got, this is a 21.5-meter tall tree. And I just want to show you what is the tangent of a 31-degree angle. If we just type in tangent of 31 degrees, we get 0.6. And isn't that what we got a bunch right here? We know it's 0.6. We figured out that ratio. So we get 0.6000, right? Pretty exact. So this idea of using that fact that in any ring, in any triangle, we're going to get 0.6, that's what's going to help us figure these out. So let's just jot down what the trig ratios are so you know what they are. We know the sine, everybody's heard of the sine, is where you don't use the opposite and the adjacent. The sine is where you take the opposite side over the hypotenuse. So I'm going to call this the sine of angle A equals the opposite over the hypotenuse. The cosine of angle A equals the adjacent side, the touching side, over the hypotenuse. And the tangent of an angle is what we were just doing, the opposite side over the adjacent side. So we've got three ratios we can use. And when I was in school, believe me, you're lucky you have a calculator, because when I was in school, we had to look at these huge tables, and it was sort of like looking through an encyclopedia to figure out what, because somebody wrote down all these numbers. The last thing I just want to let you know is if you are using this on your calculator, which we're going to do on a calculator, if you don't have a graphing calculator, you can just open a Desmos.com window and click on the scientific calculator is easier, and it will automatically come with, you'll see a little button that says DEG. It's already in degrees. You can, so if you click the button, you'll see it'll say radians, but you do not want to use radians yet. We're just going to stick with degrees. So let's just try a few quick examples here, and then you should be good to get started experimenting here. Let's say we have this triangle, and this is a right triangle. We're only talking about right triangles. So I just made up some nice easy numbers like a 10-degree angle and an 80-degree angle. Let's use a calculator to figure out what is the sine of the 10-degree angle, right? So without knowing any of the, side lengths, all I need to do is type in sine of 10 degrees, right? And hit enter. Oh, and we get 0.173 about point. So I just want you to try a few of these and try what is the cosine, just to see what these things are of a 10-degree angle so you can practice using it, and that's 0.985 about. What is the tangent of a 10-degree angle? 0.176. So that's funny how close that is, but 0.176. And now I just want to see if you should be able to try this. And try and hit pause on the video and see if you can do the next ones on your own. What would be the sine of an 80-degree angle? Just see if you can figure these out right now, okay? Just so you can get the basic idea. What is the sine of an 80-degree angle? And then turn it back on and check your work with mine really quick, okay, right? So we do sine of 80, 0.985. Cosine of 80, 0.173, and tangent of 80. That one's different, 5.67. So now looking at these, what do you notice? Some of these are the same. Why do we think that the cosine of a 10-degree angle is equal to the sine of an 80-degree angle? Let's give them some letters. Now, when you're looking at right triangles, often opposite angle A, we have small letter A. Opposite capital B angle, we have little letter B. And opposite right angle C, we have the hypotenuse is C, right? So let's just see, what would the cosine of a 10-degree angle be? Cosine is adjacent over hypotenuse. So we're going to look at the adjacent side to this 10-degree angle is B, divided by the hypotenuse, right? C, B over C. What is the sine of an 80-degree angle? The sine of an 80-degree angle, reminder, it's the opposite over the hypotenuse. So the sine here is opposite side, B over hypotenuse, B over C. So you see it's relative. The cosine of a 10-degree angle is not equal to the cosine of an 80-degree angle. And in fact, in this case, they're the same ratio. The cosine of a 10-degree angle is the sine of an 80-degree angle, and similar for the sine and cosine the other direction as well. So if we were just to say you know the sides, but you don't know the angle at all, let's just try and look at that question for a moment. Really quickly here, just to get an idea of how to use your calculator a little bit better. If that's the case, and you're not sure, right, we can look at a problem like this and say, well, I'm going to use something called the inverse tangent, and you get that by hitting your second button first. Sorry, I'm trying to get that so you can see it a little bit better. And you get that by hitting your second button, and then your tangent button, right? So second tangent, and see how it says little tangent with a -1 right there? And then we'll type in what you know. So let's actually write down what we do know for this problem. So in this case, we could write that the tangent equals, so the tangent of this angle, theta is what we call that, it's a Greek letter, equals opposite over adjacent, right? So equals 8 over 15. And again, if we wanted to solve that, in this case, since we're going backwards, we're going to actually type into our calculator the inverse tangent, which looks like this, tangent to the -1 of theta, which is just any angle, equals 8 divided by 15, and we'll put that in parentheses. So let's type that in. Inverse tangent of 8 divided by 15, close our parentheses. Oh, it's a 28-degree angle. So we could say theta is 28 degrees. And that kind of looks like it's about 28 degrees. So you can go backwards and you can get angles too. So if we were just going to try some of your first problems that were in your assignment on page 645, let's just sort of practice typing in things like the sine of a 37-degree angle. And you don't have to hit the parentheses unless you're trying to multiply it by something. That's 0.602 approximately, right? So I just want you to practice doing a few of these, and then maybe we should just look at, like, I think once we've done 1, 2, and 3, we should look at one like problem 4 for a second together. So I'm going to jot down problem 4 for us. 4 and 5. 4 says, what is the sine of a 40-degree angle? Because we know that it's some side over the tangent, over the hypotenuse, which is 18, right? So remember that the sine is the opposite side over the hypotenuse. So in order to do this, let's put it over 1, and let's just see if we can solve this proportion. X times 1, or x, equals 18 times the sine of 40 degrees. And if we were typing that into our calculator, we would just type in 18 sine of 40, and it tells us that that's about 11.6, 11.57. So if I was looking at a 40-degree angle, I would have an opposite side of 11.57, which sort of makes sense. But now let's look at number 5. It's just slightly different, and then I'm going to let you work on your own here. Cosine of a 52-degree angle equals 19 divided by x. Again, make sure you put this over 1 so it looks like a proportion, right? Because now we actually could write x times the cosine of a 52-degree angle equals 19. But that doesn't really get x alone, so we should probably divide both sides by that cosine, right, of a 52-degree angle, and that's going to make it a little bit easier to solve. So we can get that x equals 19 divided by the cosine of a 52-degree angle. So let's write that. 19 divided by the cosine of a 52-degree angle. And we get, x is 30.86. And we know how long the hypotenuse would be because the cosine of a 52-degree angle, right, is think about what that means, the adjacent side divided by the hypotenuse. So here we've got the hypotenuse. Come on to a meet if you want some help looking at some of the trigonometry, and we'll talk through some of it, okay? Thanks. Good luck. Have fun. It's really fun stuff.